Today we are going to be learning about the volume and surface area of pyramids. You might already know about the famous pyramids that you see in the picture from Egypt, but in geometry we have a lot of different types of pyramids. In geometry, our definition of a pyramid is a 3D object that has a polygon as a base and triangle faces which meet at a point called the apex. So here we have a triangular pyramid. We know this because its base is a triangle. We can also have a square pyramid with a square base, pentagonal pyramid, hexagonal pyramid, and even a decagonal pyramid. We already learned that the volume of a cone is 1/3 of the volume of a cylinder. In the same way, each of these pyramids are 1/3 of the prism with the same base and the same height. Another way to put that is that the volume of a pyramid is 1/3 times the area of the base times the height of the pyramid. So let's do a few examples. Let's start with a triangle pyramid. Here we have our formula. I'm going to write it up at the top. We have volume equals 1/3 of the area of the base of the pyramid times the height. Now the base of this pyramid is a right triangle. So I'm going to label the sides of my base, which is a triangle, calculate the area using the formula for area of a triangle, 1/2 base times height, plug in my base and height, and when I calculate that, I get that the area of the base is 6. Now I need to find the height of the pyramid, which is 4 miles. I'm going to multiply the area of the base times the height, and then multiply by 1/3. When I calculate that all out, I get that the volume of this pyramid is 8 miles cubed. Let's try another example with a square pyramid that has a square base. So first I'm going to find the area of my square base. That one's easy. That one's just base times height, 11 times 11. I get that the area of the base is 121 centimeters squared. Now I'm going to multiply the area of my base times the height of my pyramid, which is 12, and then multiply by 1/3. When I multiply all of that out, I'll get 484 centimeters cubed as my volume. Now let's try an example with a pentagonal pyramid. This means that our base is a pentagon. In order to find the area of the pentagon, we need to know the apothem of the pentagon, which they gave us is 8.3 yards, and the side length of the pentagon, which is 12 yards. So just like we did in class, I'm going to break this pentagon into right triangles. We're going to use our area of a triangle formula to find the area of this triangle, 1/2 base times height. And we have 10 of these right triangles in our pentagon. So I'm going to multiply the area of one triangle by 10 to get the area of the whole pentagon. When I do all of the math, I get that my area of the pentagon is 249 yards squared. So now we're going to plug it into the formula, take the area of the base times the height, which is 11 yards, and multiply by 1/3. When all is done, I get that the volume of this pyramid is 913 yards cubed. Now we're going to talk about the surface area of pyramids. Just like we did with finding the surface area of any other 3D object, we're going to find the area of all of the faces and add them together. For a pyramid, we'll always have one polygon base and then a bunch of different triangles. Sometimes the triangles will be the same if our base is a regular polygon, which means the polygon at the base has all equal sides and angles. But if our polygon base is irregular, meaning some of the sides are different lengths, then our triangles on the sides might have different measurements. Similar to a cone, it's important that we use the lateral height or slant height when we're finding the area of the faces. So here's an example of where the slant height is when you kind of pull these shapes apart when we're looking at the nets of these shapes. These are the lateral heights. Let's do another example. We're going to start with this pyramid that has an equilateral triangle base. So in order to find the area of this triangle, I still need to find the height of this triangle. In order to do that, I'm going to split my equilateral triangle into two right triangles. This is now a 30, 60, 90 triangle. So by using my 30, 60, 90 patterns, I know that the altitude is 2 square root of 3. Now I'm going to plug everything back into the area formula, and I'm going to find the area of the whole triangle by doing 1/2 times the base, which the base of this whole triangle is still 4, times the height, which is 2 times the square root of 3. When I multiply all of that together, I get that the area of the triangle is 4 times the square root of 3 centimeters squared, and if I multiply that out even more, I get that the area of this triangle is 6.9 centimeters squared. Now we need to find the area of the other faces of this pyramid. All of these triangles are the exact same because our base is a regular polygon. It is an equilateral triangle, and there are 3 of them. So we're just going to use our good old-fashioned area of a triangle formula, 1/2 base times height. To get the area of this specific triangle is 12 centimeters squared. But again, we have 3 of them, so I can multiply by 3, and I'll get that the area of all of these triangles is 36 centimeters squared. Now we still need to add our lateral area to our base area. So I'm going to do 36 centimeters squared plus 6.9 centimeters squared, and we get that our answer is 42.9 centimeters squared for our total surface area. All right, last example, we have a square pyramid now. So I'm going to do the same process. I'm going to start by finding the area of our square base, which is easy because I can just do 20 times 20, and I find out that the area of this square base is 400 centimeters squared. Now again, we have a regular polygon as our base, so I know that all 4 of these triangles are exactly the same. So again, I'm just going to find my area of the triangle using the base of 20 and the height of 26. 1/2 times base times height, 1/2 times 20 times 26, and I find that my area of one of these triangles is 260. And then I can multiply by 4 because I have 4 triangles, and I find that the total lateral area, the area of all 4 triangles together, is 1,040 units squared. I'm not done though. I need to add my base area and my lateral area together, and I get that my total surface area is 1,440 units squared.